Okay. A circle, the definition is a set of all points that are a fixed distance. That fixed distance is called the radius. Away from a fixed point, that point is called the center. Again, we can see the formula here. It's x minus h squared plus y minus k squared equals r squared. This is our standard form. When it's in the standard form, the center of your circle will be at the point hk. But if in your equation they are written with minuses, when we pull them out, we need to change their signs. So when you write down your hk, both of them will have opposite signs from what you see in the equation. Both will have opposite signs. From the equation. Okay, the radius is r, but in the equation it's written as r squared. So when we find r, we'll just need to take the square root of the r squared number. So for example, we have a little standard form one right here. It's x minus 3 squared plus y plus 2 squared equals 25. I can see it's hk center, but I need to make sure I write those down with the opposite signs from what I see in the equation. So my center will be at 3, comma, negative 2. Good. My radius will be the square root of my r squared number. Square root of 25 is 5. That's my radius. Good. Okay, so for each of the following, we're going to find the center and the radius, and then we'll graph the circle. Yes. Yes. First one is already in standard form, which makes it pretty easy to graph. Its hk center will be at what? 3, negative 2. Its radius will be the square root of 16, which is 4. So we'll start by graphing the center at 3, negative 2.
Where's 3, negative 2?
Oh my lord. It means write 3 down 2. Okay, and then I'm going to use my radius to count 4 up, 4 left, 4 right, 4 down. And put points that are on the end of my circle. Did you guys all bring your compass with you to draw perfect circles? Hold your hand steady. That's how you do it. I usually draw 1/2 at a time.
Yeah, that's so good.
Thanks.
I accidentally draw a square.
Just as long as it. Wow, Erica, your circle's really good. Yeah. Yours is good. Yeah.
Is this okay?
That's beautiful. Yep. What are we going to need to do for the second one? Put it in standard form, right? Which luckily for us, we know those steps now. What was my first step? Rearrange so that the x terms are near each other, the y terms are near each other. Because we're going to need to complete this square. Hold on, you shouldn't be doing a square root of 26 yet. We have to put it in the right form. It's not even in the right form yet. Okay, so thinking about our completing the square numbers. For the first one, we're going to take its b, which is negative 6. We're going to divide that by 2 and then square it. What number does that become? That becomes 9. Good. Do I have to multiply by anything when I add to the right side? No, because it doesn't have a coefficient. So you're just going to add 9. For this second one, I'm going to take its b. We're going to divide by 2, which is 1, and then we'll square that to get still 1. And then again, do I have to multiply it to add to the other side? No, it doesn't have a leading coefficient. So each of these parentheses now should be a perfect square, which means we can just write it as 1 factor squared. X minus 3, good. The second one y plus 1. And then if we simplify on the right-hand side, we get 36. So now, can we see what the center is now?
3 and negative 1.
3, negative 1. Radius is 6, because it would be the square root of 36.
I thought this was going to be so hard.
So I'm going to start by graphing my center at 3, negative 1. I'm going to count 6 up, 6 left, 6 right, 6 down to find points that are on my circumference of that circle.
Let's say hypothetically we were doing a test, and hypothetically I suck at round tackles. Would I hypothetically get the question right if I got the point?
I mean, just make sure it doesn't look like a square. That's really the key. Is make it as least squarey as possible.
I mean, even if it's a perfect circle.
I'm not judging you on your drawing skills. I'm judging you on, does it kind of look circular? Kind of looks circular, yeah. All right. We have a little challenge one on the bottom. No. It's in general form. We want to convert it to standard form.
I know what to do. I know what to do.
First step, what do we do?
Group the thingy thing.
Yep. Group the x's together, group the y's together, move the constant to the other side.
4x squared plus or no, minus 12x plus the unknown.
Good. And then we'll have our 4y squared plus 32y plus the unknown. I like that. Equals, and then if we take that 37, move it to the other side, we'll have a negative 37. Okay.
And then the next step would be group.
Yes. Each of these has a greatest, not really a greatest common factor, but we need to pull out the leading coefficient. Actually, it would be the GCF on this one. The leading coefficient of the first one is a 4, so I'm going to pull that out front.
4 parentheses x squared minus 3x plus unknown.
Good.
Plus 4 parentheses y squared.
You got it. Plus
8y
8y.
plus unknown.
Good. And then I'm going to put blanks on my right-hand side just so I don't forget to add my unknowns over here as well. All right. We're going to take b, which is negative 3 on this one. We're going to divide it by 2. And then we're going to square that. Let's keep it as a fraction. Just square the top, square the bottom. What do you get? 9 over 4. That's our number. But what are we going to add on the right-hand side? 4 times 9 over 4. Anyone know what 4 times 9 over 4 is? It's just 9. It's just 9.
How is it just 9? Oh, it erases it.
This would be 36 over 4. 36 divided by 4 is 9. Alright, we'll take the b on the next one, which is 8. We'll divide that by 2, which is 4, and we'll square that. What's 4 squared? 16. But what do we add to the right-hand side? 4 times 16, which is 64. Okay? We already did, yes. We did this times this and got this number. We did this and got this number. Okay, we ready to factor? The second one we should all know. What would my second perfect square factor into? X plus, or not y, or y plus 4. Okay, the first parenthesis though, a lot of people are like, I don't know, how do you factor when there's a fraction? Your number that goes in the parenthesis here, I don't know if you've noticed it, but it's always this b over 2 number. So whenever you do, not the b over 2 squared, it's just b over 2. So the b over 2 on this one would be 4, and it was a 4 here. On the last one, our b over 2 was negative 3, and it was a negative 3. Our b over 2 would be 1, and it's a 1. It's always just your b over 2 number. What was my b over 2 number on this one? Negative 3 over 2. Not b over 2 squared, just b over 2. Okay. And then what does the right-hand side simplify to? If I add up negative 37, 9, and 64? 36. Good. Now there's one more step. This one is different than any that we've seen so far for a circle. What is wrong with this that we normally don't have on circles? We have these front 4s that we don't normally have,
Divide each side by 4.
which means we can divide every term by 4. Yep. So now those 4's cancel. Cancel.
Why are we dividing it by 36?
We're not dividing by 36. We're dividing by 4. Because for the circle formula, it doesn't have leading coefficients up here. So we have to divide to get rid of them. So for our final answer, we'll have x minus 3 halves squared plus y plus 4 squared equals, what's on the right-hand side? 9.
So we're just trying to find the standard form, and it was
All right, let's flip it over. We're asked to write the equation of the circle and then graph. So kind of going backwards on this one. If you're given a center, remember you're given the HK. And if we think about our standard form, remember it was x minus h squared plus y minus k squared equals radius squared. So we're going to fill in everything into our equation. So for our x minus h squared, what are we going to write? X plus 2 squared, because minus this negative goes back in the equation with the opposite sign. Plus y minus 3 squared equals 9. 3 squared. Okay, and then we were asked to graph this one also.
Oh, that's easy.
I'm going to graph my center at negative 2, 3. And then I'll use my radius of 3 to find points on the circumference. 3 up, 3 left, 3 down, 3 right. As good as it gets. Oh, hey.
Gary, Gary Savage, Justin.
Oh, well, day 2. Justin's taking his notes with him, just in case. All right, let's look at the next one. Let's see how it's different. All right, we're given a center. Oh, this is important. We're given a center, and we're given endpoints on the diameter. But, again, what 2 things do we need in order to write the equation of a circle? We need the center, and we need the length of the radius, right?
We're going back to geometry.
I know, it really is.
We just go to the center and we count off from the other one, right?
I don't know if we can do that. Let's try it, though. I'm going to try to actually graph these and see what I end up with. We have a center at 2, 1. I have endpoints of the diameter are at 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then negative 1, negative 1, 2, 3. Okay. So there's a few different ways that we can actually find the length. So this is our radius here. Very good. Okay, so Danny is suggesting Pythagorean theorem. What is the other method we could use? Pythagorean theorem is one way. That is slope. We don't need slope. You could also use the distance formula, yes. Okay, I'm going to write down our two options. The first option is Pythagorean theorem, a squared plus b squared equals c squared. Oh, distance formula is way harder.
That's what I'm saying.
Okay, distance formula is big giant square root. And in that big giant square root, we're going to have
Yeah, let's not do that one.
our x2 minus our x1 squared plus our y2 minus our y1 squared. Yes, it might be easier to do Pythagorean theorem for this one. So for Pythagorean theorem, we're going to need to draw ourselves a right triangle using one of those endpoints and the center.
Technically, the distance formula is just Pythagorean theorem.
It is, yes. It is the Pythagorean theorem, just written with the points instead.
Isn't it 3 plus 1?
So I'm gonna find the length of each of these sides. So the bottom measures what? 3. What does the right hand leg measure? 4. There's a lot of side conversations that need to stop. Thank you. I'm looking at this table. And this table. Y'all are good though. Y'all are good. And this table. And y'all are good.
And us, right?
Yeah. Alright. No, Danny, you're part of the problem too. Okay. Alright. We've got our sides of our triangle measured. Remember, on a right triangle, the two legs are always A and B, and they are interchangeable. It's the hypotenuse that has to be C. So if we're trying to find the radius, we're trying to find the C, the hypotenuse. So using my Pythagorean theorem, I'm going to have my a squared plus b squared, which would be 3 squared plus 4 squared, equals whatever my radius is squared. Radius squared. So 3 squared would be 9. 4 squared would be 16. That would create, what is that, 25? 25? Okay, so if my radius squared is 25, just the regular radius would be what? 5, right? So putting together my equation now. So I'll have, the first part is my x minus h squared. X minus 2 squared, good. And then we'll have minus 1. Equals my radius squared. 25. Alright, there's my equation. Again, these also ask us to graph the circle, so I'm going to go over here and finish graphing the circle. I have 2 points that are on it. I just need kind of more points to get a better idea. But I can use my radius now to find more points. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, using those, I got enough points where I can graph the circumference on the outside of my circle now. That one's pretty good. I'm really proud of that. I got one more. Okay, last one, very similar. We're given a center, we're given a point that it passes through. Center is at 6, 1. 1, 2, 3, oh, excuse me, 6, negative 1. 1, 2, 3, 4, 5, 6, negative 1. And then we're also told that it passes through the point 3, 3. 1, 2, 3, 1, 2, 3. Okay, so this would be on the outside of the circle. So it's very similar. We're going to do almost exactly what we did on the last one, because the point that it passes through is going to help us find the radius, because this should be the radius. So from there, we'll use that as the hypotenuse of our circle. Nice. Which again, it's if 2 legs are 3 and the other is 4, what does the radius have to be? 5. Pythagorean triple. That's really.
I feel like I remember looking 3, 4, 5.
Yeah, it's called a Pythagorean triple. Okay, starting with putting in my center. We'll have x minus our h squared. Good. And then we'll have our y minus our k squared. Y plus 1. And then we'll have our radius squared. 25. Okay.